All right, we're going to get to the decimal class in a second, but first I just want to show you a couple neat things you can do with the int class in Python. So if I pass in a number as a string, it will convert it. We're casting this string 100 to the integer 100. Now, a cool trick with this class is that if I optionally pass as a second argument, I can pass a number. It will take this second argument as the base that the number should be converted from. So 100 in base 2 is 4 in base 10. And this first argument has to be a string. If I try to do 102 like that, it throws an error. So why is that? This is because when you're converting from one base to base 10, you might have things in the string that aren't numbers. So 1AB is perfectly valid in base 16, and that's apparently 427. But obviously, 1AB is not an integer, so we have to have a string as the first argument if we want to convert it from a different base. And so this int class is very cool and handy. And let's look at another totally different number class in Python that solves some of the problems we saw with floats in the last video. Remember, while floats are great at what they do, they have what's called a floating point error. And we saw this with 1.2 minus 1.0, we get something that's definitely not 0.2. And for some applications, these floating point errors can be annoying or even create unacceptable risks, like when you're working with money. And in these cases, Python has the decimal module. To use the decimal module, we're going to import a class and a function at the top of our notebook. And it's traditional to keep all imports at the top of your code. So from decimal, import decimal and get context. Import. All right. So Python has some modules, basically handy pieces of code, available by default with your Python installation. So some of these things are available without needing to explicitly import them like we're doing here, like print or float. But some of these things, like the decimal module, require you to write an import statement at the top. So this says, from the decimal module, we're going to import this class decimal and this function getContext. So if we call this function getContext, we can use it now, it returns a context object with a bunch of attributes in it. And these are basically the global settings that get applied to your usage of the decimal class. We can change any of these settings we want just by saying getContext.precision is equal to 4. Now if we call getContext again, you can see that it's changed to 4. You can instantiate a decimal class with a number value. So if I do decimal 1 over decimal 3, it returns 0.3333 to 4 places of precision. And if we change the precision to 2, let's just do that, and then rerun this, you can see that we get it to 2 decimal places. Now, if I pass a float to a decimal, 3.14, don't be alarmed. This isn't a failing of the decimal module. We're trying to exactly replicate the float that was passed in, capturing all the digits of information. So this is actually a really good example of why floating point errors arise. It's taking this float and it's saying, this is what this float exactly is. What we can do in this situation is do decimal 3.14 as a string, and that looks a bit better. So there are actually many ways of representing numbers to the decimal class, and I encourage you to check out the documentation if you're interested in using it for your own project. So should you use a decimal class instead of floats when dealing with decimals? Not necessarily. Always round appropriately before showing values to end users. Be wary of situations where you're dealing with very small numbers or very, very large numbers. However, most of the time, I'd say 98% of the time, floats are actually just fine. So instead of sending back 1.2 minus 1.0, we can round it and then return that to your users.